Alrighty, hey everyone. I don't know if you guys are here yet or not. At the moment it looks like not, but that's okay. Um, yeah, I'm just going to be here for the next probably hour or so. Whatever questions you guys have ahead of your test tomorrow, you can ask me those questions now. And if you can't make this review session, then we'll also have another one this evening. So let me just write out a couple of instructions for whenever you guys do get here. Um, all right, so here are your guys' instructions. So I'll just keep these. I'll just keep this here. Um, but yeah, so I'm just gonna hang out for the next hour or so. And whenever you guys have questions that you would like me to go over, I'd be more than happy to do that. So what I do ask, and I'll say this again once I see the audience tick count go up to one. But if you have a question about something that's been covered in a previous video, like one of the examples that we worked through talking about decimals or something, then what I need from you is if you're writing it in the chat, I need you to um lost my train of thought. If you're if you're writing it in the chat, I need you to give me the actual question, not just say like, oh, word problem two from the fractions lesson, because I don't have the lessons in front of me right now. I can pull them up if I have to, if you ask that way, but it would be easier for me and it would be faster to actually answer your guys' questions if you were to um, write out the actual problem in the chat window so I can see all the numbers, I can see the whole situation in that situation. So now I'm also going to write this in the chat for whenever you get here. Um, all right, there we go. So the details that I put on this whiteboard are also in the chat. Hey, I see the there it goes. I saw the attendance for the video had gone up to 1 for a sec. I'm just going to see if you guys are having any technical difficulties. Mhm. All right. Hey, everybody. So welcome to your review session. So I don't actually have anything prepared for you guys. But what I wanted to say is if you guys have questions, topics that you didn't understand, um, examples that you didn't understand, issues you had on the homework, anything like that. That's what I'm here for. For as long as we're doing this review session, I kind of envisioned about an hour, so like 9:15 to 10:15. I'm an hour behind you guys, so for me it's 8:15 to 9:15. But yeah, whatever questions you guys have about concepts, about specific examples, anything like that, write them in the chat or have them sent to me through Instagram or something. I've got my phone here, I've got the chat window here, and then I can go through those. Um, for specific questions, especially if it's something off the homework or off one of the videos, if you could give me the actual like numbers in the question instead of saying like, oh, question two on the homework, because I don't have the homework in front of me right now. I can pull it up if I have to, but it would be easier for me and it would be faster to solve the problems and answer your guys' questions if you can like paste the actual question in the chat window so I can see all of that information. But yeah, I've got nothing prepared for this lesson. This is your guys' class to study. And if you have questions that you'd like me to help you out with, then that's what I'm here for. So you can use this time to study. I'm going to be here. I'm going to put the whiteboard down in a sec because there's not that much written on it. But yeah, write your questions in the chat. And the second review session will be at 6 p.m. this evening. So by my calculation, that's 5 p.m. for me. But yeah, 6 to 7, that'll last for an hour. It can go a little bit over if you guys have a lot of questions. But yeah, you can use this class to study. And whatever questions you have, I am here to answer. I'll be watching my Instagram messages, I'll be watching the chat window, and that's it. I'm here if you guys have any trouble before the test. So, yeah, I'll put that down for now. But what I will do is I'll see if I can pull up the homework to have it ready just in case you guys have questions from it. But other than that, I'm just hanging out until I get a question. Awesome. So I do see that you're all here now. In case there's any stragglers that are just coming in, very briefly, I'm here for about an hour or maybe 45 minutes or so now, but up until around 10:15 um, to answer your questions. You guys can use this time to study, but if you have any concepts or specific questions from the lessons or the homework that you want me to go over, that's what I'm here for the next hour. And then also this evening from 6 o'clock to 7 o'clock. So, yeah. What is my way of doing percentages? All right, that's the question. So, it's a little bit vague because I'm not entirely sure what you mean by doing percentages. But so for instance, if I if that means like going through a problem that's working with percentages, like you know, calculating 30% of something. What I do is, let me write this out on the board, but what I like to do is I start out by turning my percentage into a decimal. So, for instance, something like something like this. So I'll turn my percentage into a decimal. So you can see all I've done is I've moved the decimal point 2 spots over because it used to be right here after the one. So I've just moved it 2 spots that way. So I've divided by 100 basically. And we end up with this as a decimal. So if you asked me to do a, a question, like if the question on the test was like, oh, um, you've got, I don't know, something that can hold 100 pounds of stuff in it, but it's only 31% full. You know, how much stuff is in there? 100's kind of a not the best number to use because that makes it an easy question. But suppose it's like you've got a bag that can hold 80 pounds of stuff, but it's only 31% full. Um, what's the weight of the bag in pounds if it's only 31% full? So for a question like that, I would take this percentage, 31%, and I will turn it into a decimal by dividing by 100. And then obviously you can get rid of the percent sign. So you're left with just 0.31. And then you multiply that by the other number. So for instance, if your question was 31% of 80 kilograms, then you turn this 31% into 0.31, and then you multiply that by this 80. And so then that's just your regular decimal multiplication. So you've got 0.31 times 80. And you can go through that problem. So you get 0 times 1 is 0, 0 times 3 is 0, 0 times 0 is 0. Um, 8 times 1 is 8. 8 times 3 is 24. And 8 times 0 is 0. Plus 2 is 2. And then when you get down to your final answer here, um, you just have to count out and make sure that you've got the same number of digits after the decimal point in your final answer as you had up here in your original. So in this 0.31, we've got 2 digits after the decimal point. In this 80, we don't have any. So in total, we've got 2 digits after the decimal point. So down here in my final answer, I just need to make sure I've got 2 digits after the decimal point. So that's this 8 and that 0. So I put the decimal point right there. And that would be the answer to the question. So that's how I would go through a question like that. If that's what you meant by doing percentages, which I hope is what you meant, what you were looking for. If it comes down to, like decimal conversion, percentage to decimal conversion, you're going to do that a lot because for all of these questions where it's like some percentage of some other number, like 31% of 80, it's always going to be a decimal multiplication problem like that. Um, if it's converting percentages to fractions, like if that's what you meant, let me know and we can look at an example of that. But this is how I would go through a question like that for percentages. So you turn your percentage into a decimal, you multiply it by the other number, and then you get your answer. And one other thing I'd like to note there is um, sometimes that other number. So for instance, here we've got like this 31% of 80. Sometimes that other number you'll find in the questions that I've given you. I haven't fully finalized the test. I'm just going to make sure all the numbers work out nicely today, and then I'll send that off. But on the test, there is a question where you have to find a percentage of a number, but first you have to calculate that number. So it's a lot like you guys would have seen this in, I think it was in the lesson, one of the lessons, or I don't think it was on the homework, but either way, it was either in one of the lessons or on the homework because that's the only place we've done these questions. Um, there's been a question where it's like there's a sales tax of 11% on some sort of a product, but the product that you're buying, it's like you're buying like two movie tickets, two concert tickets or something. So you have to do a little bit of work to figure out what that total is. So it's like, two movie tickets each cost um, $12.50. And then there's an 11% sales tax. So that's a lot of numbers. So let me write that out to show you the kind of thing you can expect to see on the test. So the test would be something like you've got two tickets. So, for instance, the kind of question you might see as like a word problem for percentages would be something like this. Obviously, I'd write out more words, but so it'd be something like you've got two, you're trying to buy two movie tickets, two concert tickets, whatever, and each ticket is costing $12.50. I would pick whatever number, but each ticket costs $12.50. And then there's an 11% sales tax. What's the total amount of money that you end up having to pay for these two tickets plus tax? So the way you would go through that type of a question, I'm going to spare doing the calculation, but like the calculation of the sales tax. But what you would do is first you need to figure out how much, what's your total cost before tax. So that's two tickets each at that. So that's, you have to figure out that your first step is taking that 1250, that looks like a 6. Taking that 1250 and multiplying it by 2 because you've got the 2 tickets. So you're going to end up with the 2 tickets having a total cost of $25. And then after that, so you've got this $25. If you've ever looked at like a, receipt from a supermarket or anything like that, there's like a subtotal before they put in the tax. So this would be your subtotal. This is just the number that's on the price tag for the items that you want to buy all put together. So that's your subtotal. You can ignore that word if that's confusing. That's just the cost of the two tickets before tax. Then you need to figure out what tax you're adding on top of that. So to figure that out, you take the $25, which is the original cost of the two tickets, and then you multiply it by this 11%. Now, 11%, to do the multiplication with the percentage, we have to turn this into a decimal. So right now, the decimal point is after that second one. So we got to move it 2 spots to the left right here. So we end up with 25 times 0.11. And then you go through that calculation, and that's going to give you the tax dollars that you have to pay on top of the $25, and then you add those two together. You're going to add together the original $25 and then the tax that you got from this number, and that would be your answer. So there's a question on the test that's similar to that. There's a question on the test that's um, you've got XYZ costs this much, you're buying two of them, three of them, four of them, whatever. Uh, and then there's this tax on it. What's the total amount that you have to pay? So this is kind of the set of steps on the test. This is about 4 marks. So if you had to get 13% of something, how would you do it? Okay. So if you had to get 13% of something, I actually didn't need to erase this entire question, but if you need to get 13% of anything, Uh, let's pick a number. So let's say, I don't know, let's say something like you had to find 13% of 45. I just picked a number. That number doesn't matter for the process would be the same uh, all the time. But so if you've got 13% of 45 is what you need to calculate, then this number does not matter at all. So you can kind of forget about it. The interesting part, the part you need to like know how to do is what to do with this 13%. So what you need to do to turn any percentage into to be able to kind of do this problem with any of these things, there's two things you need to know. You can ignore this for now. Obviously, we'll use it at some point when we're doing the calculation. What the two things you need to know are this of right here means multiplication, and this 13% needs to be turned into a decimal. So those are the two things that you need to know. Now for 13%, let's look at that. So 13%. Per means like, you know, for each, like kilometers per hour, right? Miles per hour. Um, things like that. So uh, this is like for every cent. Cent comes from the Latin for 100. So for, like this is like saying out of 100. So what you've got is 13%. It's that's saying you've got like 13 out of 100 of whatever, right? Now 13 out of 100, we can write that as a fraction. This I'm just explaining why we're dividing by 100 when we're converting percentages to decimals. So if you're saying something is out of 100, then 13% is 13 out of 100. But when you write things like this as a fraction, that's technically just a division question. It's 13 divided by 100. Now, if you have 13 divided by 100, when you divide a number by 10, you move the decimal point one spot to the left. If you're dividing by 100, that's just 10 times 10, right? You've got, so if you're dividing by 10, 10's got one zero in it. You move the decimal one spot to the left. 100 has got two zeros in it because it's 10 times 10. So you move it a second spot to the left. So your decimal point ends up right here. So you have a decimal answer of 0.13. So basically, um, okay, I see that. So I'll finish this explanation and then I'll address that. But so the way I do it is like this, that I take that 13%, I turn it into a decimal 0.13, because for me, the easiest way to answer this type of a question is once I've gotten that answer of 0.13 for my percentage being written out as a decimal, then for me, I take, okay, that 0.13, I'll write that as 0.13 times, and then now we look at that 45, and I put that here. And then for me, I really like turning questions into long multiplication problems, and I'm not worried about the decimal point. So this is the way I do it: is I turn that 13 into 0.13, and then I go through the long multiplication question. Now I do see the comment that you've left that's the kids do 10% and then 1% three times. That's also totally okay. Um, one thing you should know is that the percentage I've given you on the test is one that's easy to work with, because I don't want it to be, I don't want to give you a number like 13.5% or something. That's just, it's a lot of work. There's a lot of places you can go wrong. So the percentage that you have on the test is easy to work with. I'm not telling you what it is, but don't stress too much about that. But that's a perfectly good strategy as well. You can do 10% and then 1%, 1%, 1%. That's totally another way to do it. But yeah, that's the neat thing with these kinds of problems is uh there isn't just one right way to do it, right? You could do this a few different ways. If you're, for instance, if you're super comfortable with fractions, you turn that 13% into 13 over 100, and then you do the question, you turn it into a fraction question, right? For me, I prefer decimals to fractions, so that's why I turn it into a decimal. If you would prefer to cut it up into, chunks of hundreds and tens and ones and then kind of keep everything set kind of like that, that's fine too. So yeah, whatever works for you, that's totally reasonable. Yeah, so that's something I should have said or emphasized more in the lessons is that my way is not the only way. If you have a way that works for you, that's totally reasonable. And actually, for those of you that don't like or struggle with long multiplication, I'll have to dig it out, but there is a video from like October 2019, um, where I teach a sort of secondary way of doing a long multiplication question, and it can be used for decimals as well. So if you guys are bored this weekend, not this weekend, it's Monday, if you guys are bored, after studying everything and you just want to practice a little bit of long multiplication or something, check out this video from around September, October 2019, and you'll find sort of an alternate way of doing this kind of a question. But yeah, so that's my way of doing the question that you've posted here. This 13%. Yeah, you can do it a variety of ways. You can do 10% and then ones. You can turn it into a fraction. You can turn it into a decimal. Whatever works for you. And this isn't something that I don't think I mentioned this last week. But I'm I'm gonna make sure today before I send out the test and the answer sheet. I'm gonna make sure that all the numbers work out to like pretty nice numbers in all the questions, because I don't want you guys to use a calculator for the test. So you don't need a calculator for this test. Later on in the semester, if you'd like to have a calculator, you can. The thing with a unit like this one, where we're talking about fractions, decimals, and percentages, is that if I've given you a question like 0.13 times 45, like this one that we were just looking at, 13% of 45, and you do this first step of turning the 13 into a decimal, and you know that of means multiplication, and you get to this point where you've got this 0.13 times 45. The whole thing I want to see, well, there's two things I want to see, right? The first thing is I want to see that you can do this, that you can turn this 13% into this 0.13. But then I also want to see that you can do this long multiplication and get the right answer at the end of it. So that's why I don't want you to have a calculator for this one, is I don't want you to punch this into your calculator uh, and then just spit out the answer down here. That's why I want you guys to show your work. I want you to show what are you doing to get your answer, so that even if you make an addition mistake, a multiplication mistake, if I can see that the process is right, you'll get most of the marks for it. But on future tests, once we get into algebra, once we get into linear functions and quadratics and all those scary terms from the first lesson, at that point, if you do well on this test, then now I know you can do decimal multiplication. So at that point, I don't care if you can do decimal multiplication again. Um, uh, so in that situation, you'd be allowed to use a calculator to help you kind of speed along through the question. But yeah, so for tomorrow, no calculators, but later on in the semester, we will look into that. Can you do some examples of long division? Absolutely. So if we look at let's do some examples. I presume you mean decimal long division, but it's basically the same as regular long division. So, suppose we had something like, suppose we had something like 19.6 divided by 7. Okay? So, uh, this is a decimal long division question. It's a decimal division question, and I'm going to solve it by doing long division. So, A couple of things I'd like to clear up. We want to find, obviously, the answer to this question. We don't know what it is yet, but just the terminology I'd like to clear up in case you've forgotten or never seen it before. This 19.6 is called the dividend. So that's the name for like the first number in your division problem, right? So the number that you're dividing by another number is your dividend. The second number, the number that you're dividing by, is your divisor. So the dividend is divided by the divisor, and the answer is called the quotient. And now that's hopefully something you guys have seen before. I wanted to say that once just because I want to make sure that if you're doing decimal long division, um, I want you to make sure that you're setting up your problem right. And the way I was going to explain that is make sure you put your dividend under that like weird shape that we make for our long division problem and put your divisor over here on the left on the outside. So I'm going to rewrite this in a sec because I need room to work kind of downwards. But I just wanted to make sure that this terminology is clear that your dividend goes here, your divisor goes here, and your quotient is what sits on top. So those are just the words. You don't have to memorize that, but it'll just help you follow along in my process here. Now, let me just erase that and write it a little bit better. I'm going to get rid of those labels, dividend, divisor, and quotient, and then we're going to do this problem of 19.6 divided by 7. Now, if you feel comfortable with division already, with decimal long division, um, try and solve it like before I do. Try and work through it right now while I'm working through it at a bit of a slower pace and see if we get the same answer. So, so yeah, I'm going to write 19.6 like so, and we'll put a 7 right there. So that's our problem set up as a long division question. So the first step in a long division problem is because it's a decimal long division problem, we can just ignore this decimal point right now if we wish. I'm actually going to do it a little bit differently. I'm going to line up this decimal point with the decimal point in my quotient. So I've taken this decimal point and I've just thrown it upwards. It's sitting directly above this one. So that's where the decimal point is going to live in my answer. Now, you don't have to do this as your first step. You can do it as your last step. The reason I like to do it as a first step, and why I like to teach doing it as a first step, is that it's really easy to forget at the end to go back and put in that decimal point, right? Because regular long division, you don't have to worry about that. But decimal long division, that's a step that you have to think about. And because you originally learn long division without it, it's really easy to forget. So the first step you should do for decimal long division is throw that decimal point up at the very top so that you can see it in your answer and make it nice and big. Um, Try doing one with multiple numbers as the divisor. Multiple numbers like a two-digit number? Okay, I'll do that. I'll do that next. Yeah, I'll do that next. But we'll start with an easy one just because I want to make sure everyone's on the same page, and then we'll do a slightly harder one. So the first question we have to ask ourselves here is how many times does 7 go into 1? It three digits is the divisor. Okay, we'll get to that. Okay, so the first question we have to ask ourselves is how many times does 7 go into 1? It doesn't. So we move on and ask how many times does 7 go into 19? And the answer is twice, of course. So we put a 2 up there. 7 times 2 is 14. So we put that right here and we subtract. 19 minus 14 is going to be 5. And then now we pull down this 6, and we can ignore the decimal point. You don't need the decimal point except putting it up there in your final answer. Um, So then the next question is, how many times does 7 go into 56? And the answer to that is 8. 7 times 8 is 56. And because that lines up so nicely, we end up with a remainder of 0. And that's it. You'd be done the problem at this point. Now, the thing to remember with decimal long division is that as soon as you hit this 0, you're done. But if you don't have a 0, if you had another number here, if you had something else here, then you have to put in a 0 right here and drag that down and keep working and keep adding to this up here. So if this wasn't 19.6, but if this was 19.7, that's a disgusting 7, then you'd have had a 1 as your remainder. And then now you have to throw in this extra 0, pull that down. How many times does 7 go into 10? And then you have to kind of keep building on it like that. Now, for the question in the comments, that problem is too easy. Try doing one with multiple numbers as the divisor. And then you've written 3. So like 3 digits as the divisor. So 3 digits as the divisor is going to be a really big number, right? Right. Because so the reason, so I'll show you kind of what I'm understanding from it is, so suppose you had, you want to divide by a 3-digit number. So for instance, you have something like, suppose you have something like 1,024 divided by 314, right? Or if you turn this into a decimal problem, you can put decimals wherever you want. You can make this 10.24 divided by 3.14. You can do whatever you want to make it as complicated of a problem as you want. The thing is, I will steer clear of this type of a question for now and for the test, because working with many digits in your divisor ends up just it ends up being a little bit harder to work with, to the point that I don't want to make everybody do that on the test. So the reason that is that if you set this up as a long division problem with or without the decimal points, I don't care because we're coming up with this on the spot, and you put uh, this 3.14 right here. Suppose we suppose we multiply both of these numbers by 100, so we move the decimal point 2 spots to the right just so we can get rid of them. And now we're dealing with 1,024 divided by 314. You end up having a really hard time figuring out how many times the divisor goes into the dividend because you have to count by 314 every time, which isn't the easiest thing to count by. So long division works really well when you're dividing by a single digit number or maybe a 2-digit number. But after that, you're starting to do this like really huge, like, kind of guess and check addition problems in your head to work out how many times this goes into that. Like if we were to look at this, even if you were to put decimals in somewhere, you're going to end up basically asking yourself, how many times does 314 go into 1? It doesn't. How many times does it go into 10? It doesn't. How many times does it go into 102? It doesn't. How many times does 314 go into 120, into 1024? Now all of a sudden you're just adding 314 to itself, checking what the answer is, and then if it's still smaller than 1024, you're adding another 314, and you keep doing that until you hit it. So with big divisors, with divisors that have 3 digits, 4 digits, 5 digits, it's really complicated to work through that doing long division. It is possible, but it'll take so long that it's not the kind of thing that I would put on the test. So on the test, you'll see um, long division problems with 1 or 2 digit numbers as the divisor, or like a decimal that like a divisor with a decimal, so something point something, but only 2 digits, because those are relatively easy to work with. And if you can do that, then I know that you know how to do long division, and you could do this question if you had to, but it just takes too long. It takes too long, and if you don't end up with uh, a remainder of 0, then you've got to go through this whole set of steps again, and it ends up being a big mess. So that's why I'm steering clear of 3 digits. But what we can do is we'll do one with 2 digits to make it a little bit harder. So like a two-digit divisor. So suppose we do something like, suppose we do something like, how do I want to do this? Sure, let's do, uh, maybe we'll make this even harder. I think these numbers should work out pretty nicely, but suppose we have as our question, suppose the question is 33.6 divided by 12. So a little bit bigger numbers that we're working with here instead of just you know, under 20 and under 10. But so 33.6 divided by 12. So setting this up as a long division question, we get 33.6 as our dividend and 12 as our divisor. So we set up the problem like this. And then what we're going to do is we're going to put the decimal point up there. Again, make it nice and big so that you don't forget about it. I know normally, you write out your decimal point as just like a tiny dot, almost like a period. Make it nice and big so that you don't forget that it's there, right? Um, so for this kind of a question. So we'll start the same way we always do for long division now that we've taken care of the decimal point. So we ask ourselves, how many times does 12 go into 33? Now, if you know the answer to that offhand, great. If you don't, you can figure it out by adding the divisor to itself a bunch of times. So 12 plus 12. See what the answer is. And if it's smaller than this 33 that you're working with, then add another 12 and see how many 12s you can fit before you go over. So 12 plus 12 is 24. That's still smaller than 33. So we'll add another 12 and see what we get. And we get an answer of 36. Now 36 is too big. So this last plus 12 was a mistake. We shouldn't have done that. So that means we can fit two 12s into 33. So we'll put a 2 right there. Now 12 times 2 is 24. So we subtract 24. We get down here 33 minus 24. If you want to do this by borrowing, you can. So the 3 minus 4, obviously you can't do that. So this 3 becomes a 2, and then you put a 1 there. 13 minus 4 is going to be 9, and then 2 minus 2 is 0. So there you go. You end up with 9, and then you pull down this 6, ignoring the decimal point, right? Because all that this decimal point is doing is it's lining up with the decimal point that's up there, and that's it. That's all that matters. So now we look at this 12 into 96. How many times does 12 go into 96? So again, because we're dealing with bigger numbers here, maybe you have to go through this process of adding 12 to itself a bunch of times. So if you do 12 plus 12, that's going to be 24. That's smaller than 96. So you add 12. That's going to be 36. Still smaller. So you add 12 again. That's going to be 48. Still smaller. You add 12 again. That's going to be 60. Still smaller. You add 12 again. That's going to be 72 because this was 60 plus 12, right? 72. It's still smaller. So we do it again. We get 84. And then we do it again. And we get 96. So how many 12s do we have here? We've got 1, 2, 3, 4, 5, 6, 7, 8 12s that we've added together to get to 96. So that means that 12 times 8 will get us to 96. So we take this number, we put that there. So that's 96. 96 minus 96 is 0. And there's your answer. Huh, we got 2.8 again. Okay, interesting. I definitely did not mean to keep doing that. I promise the test is not going to have a question that has an answer of 2.8. But there you go. So that's how you would do this type of a question where you've got slightly bigger numbers as your dividend and your divisor. The thing I'd like to steer clear of on the test, just because I don't want to confuse you, the place where things can get confusing is where your divisor is bigger than your dividend. So for instance, if this wasn't 33.6, but if this was 3.6, then your first answer, your first digit in your answer, in your quotient, is going to be a zero because you're dividing by something so big that your answer is going to be less than one, right? Because each, if you were to cut up 3.6 into 12 pieces, each of those 12 pieces is going to be smaller than one because it has to be. Um, so because that gets a little bit confusing, I'm steering clear of that on the test. Now, we might run into that at some point later on in the class. When we get into harder topics, you might run into questions where you've got to do this kind of step of decimal division somewhere in a bigger problem, and you end up with an answer of 0 point something. So you could absolutely get that. And one other thing that you could get and that you should know how to do is sometimes, and I don't think I've put this on the test, but I might put it on the exam at the end of the year, maybe, is you might have a question where your divisor also has a decimal point in it. So normally, the questions we've been doing, the dividend has a decimal in it, but the divisor is just a whole number. It's a 7, it's 12, it's an 8, it's whatever. But you could have a question where you've got something like, recess. Excellent. Um, yeah, so I'll just finish this thought. But so for instance, you might have a question like this on the exam. So something where you've got a decimal in your divisor, maybe also in your dividend, maybe not. But but yeah. Kids may be in touch later. Okay, cool. Yeah, so at some point, because you guys have gone for recess, that's great. Uh yeah, because you guys have gone for recess, I won't go into too much detail here, but something that we might touch on before the exam is how to handle a division problem where you've got a decimal in your divisor. Now, I'm not going to worry about that for tomorrow because if you have studying left to do for the test, you shouldn't be wasting your time on something that is not going to be covered tomorrow. But we will talk about this at some point, hopefully, if time permits. And then you might see something like this on the exam. I do see the comment. It's gotten really noisy now due to recess. I don't think we have any more questions for now. Some of the kids may be in touch later. Awesome. Yeah, my pleasure. I will hang around for like, what is it, 10 more minutes, just because I kind of said it would be like an hour. So I'll hang out until 10:15, in case there's any like last minute urgent question that somebody comes up with outside. But yeah, thanks for tuning in. I will be on again at 6 p.m. until 7. So if you can tell the kids that, that would be great. I'll be on again, same kind of setup, same, YouTube live and all that. Uh, they might have to find me themselves because they'll be at home. So just make sure they all know how to get to the channel. Um, and yeah, that's it. I'll be hanging out for a little bit and then I will be on again at 6 p.m. in case the kids have any other questions. All right. So by my clock, it's 9:15, or I guess 10:15 Dominican time. So I will head out for now. But if anybody's listening to this still, yeah, just let the kids know that I will be back on at 6 p.m. Dominican time. Have a good one.